Okay, back again working on this Amiga 2000 upgrade. I finally got a bracket for my SD to SCSI adapter. Nice little universal unit that actually fits several of these. Fairly cheap to have it 3D printed using one of those services. I don't have access to a 3D printer handy, but it came, and only thing I really had to do is use my drill here with a 7/64 bit to drill out some of the holes. As you can see, it left a mess here. I didn't film that because that would have been a difficult operation to do and film it at the same time. But it mounts in here nicely, and also I was worried that I might have to buy another one of these because I got this external connector that for the first mounting plan that didn't work out, but it has clearance. It's not touching anything. I then use these 3.5 inch to 5 1/4 inch brackets that I had extra, and switch my hands here, and should fit in there nicely. So to get this really properly mounted, I'm going to have to remove the accelerator card, but that's good because there's two things that I wanted to do. One is, when I got this accelerator board, one of the things that they mentioned to me was that it didn't seem to fit in the cases that they had tried. Something was slightly off with the board, and so definitely you can see here I got it to fit, but it is bowing a little bit at this end. And the suggestion, what they had on the original eBay listing, was to actually mount this faceplate on the outside. So that might be what I'm going to end up doing. So I'm going to take that out. And then the other bit of kit that I want to install here, and I'm going to try and video me doing this, is another Indivision product. This is a 2 megabyte chip RAM expander that I don't really need, but I bought because it was cool, and it should allow me to do some better screen resolutions, because this is an OCS machine with 1/2 megabyte of chip RAM. So anyhow, we'll do that here in a bit, but first I'm going to take this, now that I got this bracket, and even though I've actually already done this, I'm going to now show the little video I have where I program this thing. I want to have either 2 or 3 hard drives on it. It's got in it an 8 megabyte or 8 gigabyte 8 gigabyte card, and I don't want to have just one big 8 gigabyte disk. Number one, because that's at least with Amiga S3.1, that's not compatible. 2, that's a lot of space on a Amiga. And 3, these SD cards really weren't designed to be used for hard disks, or for, rather, I should better say, weren't designed to be used as operating system main disks. And as you may or may not know, the flash storage is such that you can read from it as many times as you want, but it has a limited number of times that you can write to it. And the way they get around that in this kind of technology is they use something called write leveling, where they kind of randomize how they write data on the device. So by provisioning this lower than the actual total size of the card, I'm giving it more space to do that write leveling. Not that that really matters. The Amiga OS as an operating system, at least in the versions I'm going to be able to run on this machine, is not very heavy on write operations. Unlike, say, operating systems like Linux and Windows and those that have a swap file. So if they don't have real memory available, or sometimes even if they do, they keep portions of memory for unused programs written to disk in a swap file. And as you can imagine, that's a heavy read-write thing. The Amiga OS doesn't do that by default, although there are programs that add in that functionality. But so it's not really so much of a worry with the Amiga OS. I may also try and run NetBSD68K on this machine too, where definitely that uses a swap file. But we shall see. All right, moving on. Let's talk about SCSI for a bit. So the best way to think about SCSI is that it's a very long cable. And to this cable, we have attached various things. So you may have a hard drive, you may have a CD-ROM drive. Excuse the art skills here. You may have a tape drive. And of course, you also can't forget that it's connected to the computer itself. Usually, this special device here, it's supposed to be a computer, this special device here is called your host adapter. Now, each one of these has to have a unique ID on the bus. So this one could be 1, this one could be 2, this one could be 3, this one could be 7. Now, in SCSI 1 and SCSI 2, these are represented by 3 bits. And thus, you have a total of 8 devices. And really, in practice, it's 7 devices. Because remember, one of those devices on the SCSI bus has to be your host, your computer. But it doesn't have to, the computer doesn't have to be any specific device number, and you're left to number these how you so choose. I tend to like to have my host computer as 7, and then I can go 0 through 6 for all of my different devices. 0 being my primary hard drive, and then other devices going from there. So, this is the beginnings of SCSI. The next thing that we have to think about in our case is something called termination. So, at the end of these long chains, at the end of this long cable, we put these items that we call terminators. And the purpose of these is really for signal clarity. So when one of these devices sends a signal out on the bus, it goes out in all directions. And then at the end of the cable, these absorb that signal so that it doesn't kind of bounce back. And I don't know quite the electrophysics of it, but basically it helps with signal clarity. Now, you don't need terminators necessarily. A SCSI bus will work without them, but for optimal performance and all of that, you need to have everything terminated. Now, and that termination goes on both sides of the cable. So, in my SCSI utility here, where it says enable SCSI termination, I want to do this only if my SCSI 2 SD card is on one of the ends of this cable. So in this example, if my SCSI 2 SD card is here and it is the last one, I want to enable termination. But let's say it wasn't. Let's say that I had another device here that maybe was like a floppy disk drive. I don't know. Or something. some other kind of SCSI device, or maybe like a flatbed scanner. I don't know what that is, but we'll go with that. And then this guy would have an ID of, say, 0, right? In this instance, my SCSI 2 SD is in the middle, so I do not want to enable termination, because what that means is that signals from here over and from here over will not get from either side, signals from either side of this will not transit over. So you don't want to do that. But if this is on the end, you want to enable it. So if this were to, if we were to take away our last couple of edits here, and this is what our bus looked like, we would want to enable SCSI termination. But if we had another device there, we would not. So I hope that makes sense. So, in brief, both of the ends of the SCSI cable must be terminated. Every device must have its own unique ID. If you follow those two rules, you'll never have any trouble with SCSI. At least I hope. Now, with that information in mind, let's configure our SCSI 2 SD device. So the first thing to do here is to plug it in. Now I'm using Linux for this. Conceivably you could use other operating systems, but why? So first and foremost, I plug it in. If I do dmessage here, I will see that I have two HID raw devices that show up from code source. Now, I'm using Fedora, and in the default configuration for this, if I look at dev HID raw 0, you see when I plug it in, it's owned by root, and it's read-write only as root. So if I were to run the SCSI 2 SD configuration utility as my user, which I want to do, I couldn't get to it. So I'm going to temporarily change all those HID raw devices to 666, which means that everybody can read and write them. So if I go back, log out here, and now I'm my own user again, I've downloaded the SCSI 2 SD util. Comes up a bit off screen, but here it is. So fairly simple GUI. It's found my device in 512 byte sectors. I have roughly 16 million of them, which if I were to convert that to 1K, that means I have a roughly 8 gigabyte device, which is what I have. So I have 8 gigabytes to play with. The first here screen shows general options, and a lot of these are for special cases or picky SCSI devices. Some SCSI controllers are more particular than others. The only setting that I'm going to smash here is going to be this enable SCSI 2 mode, and also enable SCSI termination. If you remember from the previous one, the location of the device on the SCSI cable determines whether or not to set this. Mine happens to be at the end of the internal SCSI cable, so I want to enable termination. Next, I want to set the various devices. So I can set up to 4 hard drives. I can carve this SD card up into 4 hard drives, and I'm going to do so. This GUI makes it fairly easy to avoid overlap by setting the auto setting on every one that you want to enable. And if I do so, it's going to optimally calculate this. So I want a 1 gigabyte device, a 2 gigabyte device, and a second 2 gigabyte device. So as we can see, it calculates these all where there's no overlap. So this one starts at 0 and goes to about 2 million. This one starts at 2 million and goes for approximately 4 million sectors. 2 plus 4 is about 6, so device 3 starts at about 6 million. So this does really most of the hard work for you. We could, if we wanted to, enable different device types, but I'm just going to stick with hard drives. And then there's Quirks modes for various finicky SCSI adapters. The one that's involved with this TechMagic QuickPack, or this TechMagic 68060 adapter, is not very finicky, so I don't have to worry about that. So I now have 3 devices enabled, which is great, of varying sizes. They, of course, all have to fit into 8 gigabytes, which 1 plus 2 plus 2 is 5, so they do. Now, the only other thing that I like to do here is to modify the serial numbers. I'm going to set 1, 2, 3. And the reason I do this is just to limit confusion. In the real world, for real discs, every disc is going to have a product ID or a vision number and then a unique serial number. And so if I have all of these be the same serial number, which by default they appear to be, then that could cause some confusion. So I put in my own serial number here just to make sure that everyone has its own unique one. Now, if need be, I could also mess with the vendor, the product, the revision, if I wanted to try and fool the computer into thinking this was a particular drive. Some things that's necessary for, but for the Amiga it's not necessary. So, got all those set up. Everything's looking pretty good here. So now I would go to File, and I could save all these settings to a file, which may not be a bad idea. But to really, where the rubber hits the road, I want to save it to the device. So this is going to program the flash array in the device. And it doesn't take very long at all. And now once this is done, this is ready to put into my Amiga.